Welcome to the CompTIA Network Plus N10 008 examination. This is Chapter 3, Ethernet Basics. Okay, let's take a look at the objectives. I'm going to read them. 1.3, summarize the types of cables and connectors and explain which is the appropriate type for a solution. 2.1, compare and contrast various devices or features and their appropriate placement on the network. 2.3, given a scenario, configure and deploy common Ethernet switching features. 5.2, given a scenario, troubleshoot common cable connectivity issues and select the appropriate tools. Okay, so where do we start with the basics of Ethernet? Does this picture look familiar to you at all? Well, to me it looks quite foreign. I wasn't quite sure what it was. However, Xerox in 1973 invented the Ethernet cable. And by the time in 1979, they decided to expand and work with Digital Equipment Corporation and Intel to make it more standardized and adaptable. Okay, and then here we have the different standards. So these are called 802.3 standards, which are for the hardwire cables. So let's take a look at the different standards. We have 802.3i, which is 10 megabits per second using twisted pair cabling, which came from 1990. And if we jump all the way down to the bottom, 802.3cu, which has throughput of 100 gigabit to 400 gigabit Ethernet over fiber. Those are huge changes in just about 30 years or so. We can see the Cat5 cable, the Cat5e and the Cat6a, and the different networks they support. It's pretty common to see gigabit everywhere in the office nowadays, so I find Cat5e and Cat6 are pretty common. Okay, moving on to Ethernet frame. What exactly is an Ethernet frame? Well, we're going to break down the different parts of it. So the first part is a preamble. It's used to synchronize the different data. Okay, and then we'll have different information like a destination address and a source address so it knows where to go. The type of data, and maybe it will say IPv4, IPv6, different things like that. And then the data itself, and then there will be some sort of error correction at the end, a CRC, or sometimes we say FCS, to frame check sequence to make sure the data arrived gracefully. So we are starting to standardize a lot of things. So one thing that is becoming common is the 10 base T, or how we will deliver Ethernet connections on a network. So we already talked about the different pairs before. Let's focus more on the network we see over here and the different infrastructure. So 10 base T is coming to the switch, and then from the switch it'll go to the different computers. So there could be fault tolerance. If a cable dies, it doesn't bring down the whole network. It's easy to switch a computer in and out. So there's a lot of different advantages, similar to how the other topologies work. Okay, and when we look at the tech specs of 10 base T, we saw that as 10 megabits per second. So that was the same as in the 1990 throughput that we saw. It's a baseband. It can travel 100 meters, no more than 1,024 hosts per hub or node. Okay, topologies varied, and yeah, we need at least Cat3 or better to run a 10 base T. And you can see the different wirings of A and B here. Okay, this is actually not on the exam. If you're trying to get a legacy network to work with fiber, you actually can do that with the 10 base FL. I'm not going to go into detail in it because it's not on the exam, but if you want to pause the video and read that, you can. Okay, so before we learned about collision domains. So the problem was we would send a frame or a packet to the hub here, and then sometimes people would collide because they're sending data at the same time to that port. So how did we get around this? Well, we created a collision detection, which a host would randomly roll a number and be assigned a number, and that is kind of the queue, and it would wait in line for the data that it wants to receive. So each host rolls for a random number to prevent collision, and this is how we resolved collision in the old hub days. Okay, and finally, we can say that we are graduating from a hub to a switch. So in 1990, the switch was invented. Hubs are not so intelligent pieces of hardware. All they do is repeat a signal, and they can have other problems like collision and different latency. It's just repeating signals. However, when we made a switch, we did things a bit more intelligent. We analyzed the MAC addresses and we made a table and we assigned it to each one. So then that way the switch knows exactly who is getting what data and it doesn't have to repeat it. So here let's talk about the uplink. The uplink is quite important on a switch. It'll allow you to connect multiple switches together. Alternatively, you could use a crossover cable from a A to a B instead of having an uplink, and that would connect switches together also at a less managed level. But when you're able to connect all these switches together, then you can make a much larger network or segment it differently. So like we're talking about, we had uplinks. So it's pretty cool that we can do this, but what if we made a mistake? What if we looped a switch back to itself, or we did something improper? Let's talk about the spanning tree protocol. So it's common that you would have this mistake or you would make an error and create a loop. So the spanning tree protocol is a network protocol that builds a loop-free logical topology for Ethernet networks. It uses STP to prevent bridge loops and broadcast radiation. So that was quite common for all this broadcast data to be going across the network if there was a loop, and eventually it will create a lot of latency and problems. Okay, so that's the end of Ethernet basics. Let's take a look at our pop quiz. Number 1, what are the different parts of an Ethernet frame? Number 2, how fast is 10 base T? Number 3, how did hubs resolve collision? So pause the video, take a moment, think about it. Is this easy? Is this hard? Do you feel confident? So try to answer these on your own. Here are the answers. So we have different parts of an Ethernet frame that we talked about. So we'll have a preamble, which actually is not in here, but there's preamble, and then you'll have your destination, your source, the type of data that it is, the data that you're sending, and then the error correction. So this is very important for you to know on the Network Plus examination. You absolutely need to know that. Okay, how fast is 10 base T? We did talk about in the 1990s when they invented 10 base T, they were getting throughputs of 10 megabits per second. Okay, and the last one, how did we resolve collisions? Do you remember that? So hubs were not so intelligent and they wouldn't switch or route, so they had to roll for a number and make a queue and wait for the data that was repeating on the hub. And if they did this correctly, there would be no collision. Thank you for watching. Have a great day.